What if the key to treating depression wasn't carefully designed in a lab for that exact purpose, but was actually found completely by accident? Well, that's pretty much what happened. Today we're diving into the incredible history of antidepressants. And believe me, it's not a straight line. It's a story full of surprising twists, happy accidents, and a constant search to find the perfect key for the human mind.
Sounds kind of crazy, right? A failed drug for one thing, and an allergy pill for another? But these two unlikely sources are at the very heart of modern mental health care. It just goes to show you that sometimes the biggest breakthroughs are the ones you absolutely never see coming.
So let's rewind. Our story really kicks off back in the 1950s. At the time, researchers were working hard to develop new antipsychotic drugs. But then one of their experiments gave them a result that was completely unexpected, and, as it turns out, incredibly lucky. This one moment, it changed everything we thought we knew about treating mental illness.
Okay, so take a look at this. On the left, you've got promazine, an antipsychotic, and on the right, imipramine, the world's very first real antidepressant. I mean, look at them. They're practically identical. The only real difference is that single atom connecting the middle rings. Just that one tiny molecular change completely rewired how the drug worked in the brain. It went from being a sedative to a mood lifter. This was huge. It was a first real proof that a specific chemical change could directly impact depression.
This brand new class of drugs got a name, tricyclic antidepressants, or TCAs for short, just because of that three-ring structure you see. And they worked in a totally groundbreaking way. Basically, they stopped the brain from reabsorbing, or kind of vacuuming up, serotonin and norepinephrine. These are two super important chemical messengers that help manage our mood. By keeping them around longer, they had more time to do their job.
But there was a catch. TCAs absolutely worked, but they were, a bit of a blunt instrument. Think of it like a master key. Yeah, it could unlock the door to help with depression, but it also unlocked a whole bunch of other doors in the brain that you didn't want it to. And that, of course, led to a lot of side effects. And here's exactly why that master key was a problem. It wasn't very specific. So while the TCAs were great at hitting their main target, those serotonin and norepinephrine transporters, they also hit a bunch of other unrelated receptors. Hitting the muscarinic receptors, that caused dry mouth. The histamine receptors, drowsiness and weight gain. And the adrenergic ones, dizziness. The drug was definitely powerful, but it was anything but precise. So, this huge side effect problem became the next big mission for scientists. The goal was crystal clear. Could they design a drug that was just as effective at treating depression, but way more selective? Could they finally create a precision key instead of that clumsy master key?
So you can see how the whole thing unfolds. The 50s gave us this amazing accidental discovery. The 60s showed us the problem with it, and then, in the 1970s, the solution started to take shape. And it came from a place nobody was looking.
So the breakthrough hero of our story? Get this. It was an antihistamine, an allergy medication. Researchers discovered that this common antihistamine, phenyramine, had this really cool property. It selectively blocked serotonin transporters, and it didn't mess with all those other receptors that cause the TCA side effects. That was it. Suddenly, they had the blueprint for a much, much smarter drug.
Using that antihistamine as a starting point, chemists were able to engineer a whole new class of drugs. This was the birth of the selective serotonin reuptake inhibitors. You probably know them as SSRIs. This was it. This was the precision key they'd been searching for. And the difference was just dramatic. You can see it right here. The TCAs on the left, they hit their intended target really well, sure, but look at all that activity on the side effect targets, too. Now look at the SSRI on the right. It hits the antidepressant target just as hard, but it barely touches the others. It's so much cleaner. This is what specificity looks like in action. So how'd they actually do it? It was a really beautiful piece of medicinal chemistry. They basically started with the core skeleton of that antihistamine. Then, they made a very precise little tweak, adding a chemical group in just the right spot. And that one single change was enough to massively boost its selectivity for serotonin, creating a powerful and targeted new drug. And this incredible breakthrough is what gave us some of the most widely known medications in the world today. Drugs like fluoxetine, sertraline, and citalopram, they all come from this new, more precise family of antidepressants. But of course, the search for even more precision didn't just stop there. Not even close. The development of SSRIs really blew the doors open to a much deeper understanding of brain chemistry, which led to a whole bunch of new tools for doctors.
I mean, just look at the toolkit we have today. It is incredibly diverse. SSRIs are obviously a huge part of it, but those older, powerful TCAs are definitely still used. And we have other classes too, like DNRIs that focus on dopamine and norepinephrine, and even mood stabilizers like lithium. This variety is so important because it gives doctors way more options to fit the treatment to the person.
And all this choice allows for a much more personalized way of treating people. Take bupropion, for example. It's unique because it also helps people quit smoking. Or lithium, which is still the only drug we have that's proven to lower the risk of suicide in bipolar disorder. The goal isn't a one-size-fits-all pill anymore. It's all about finding the exact right key for each individual lock.
But here's a really fascinating little twist in the story. After all this talk about new, selective drugs, this quote kind of throws a wrench in things. Clomipramine, that's one of the original TCAs, one of those blunt instruments, and yet it's still considered by many to be the single most powerful antidepressant ever made.
So, what do we make of that? Well, it tells us that sometimes that raw power is exactly what's needed. Sometimes you need the sledgehammer, not the scalpel. But the overall arc of this story, from that complete accident to these finely tuned molecules, has been a clear, relentless march away from brute force and toward precision. The whole evolution of these medicines points us in one clear direction. Power isn't the only thing that matters anymore. Precision is the real goal. And as our understanding of the brain's incredible chemistry just keeps getting deeper, it makes you wonder, right? What will the next generation of truly personalized treatment even look like?